Typically, when explaining the mean value theorem and Rolle's theorem, teachers like to begin with the mean value theorem, but today I'd like to provide an intuition of these by starting with Rolle's theorem instead. Rolle's theorem has this fancy, rigorous definition that I've pulled from Wikipedia, but all it's saying is that if I have these 2 points, which I'll label A and B, so long as they have the same y value, I connect them with a curve that can be drawn without picking up my pen, and I can find the derivative of any point on this red curve, then there is at least one point on this curve where the slope of the tangent line is 0. This statement is actually very intuitive because if I want to connect my blue points with some function, I can do it with a straight line, in which case the derivative is 0 at every point on the quote-unquote curve. Or I can do it with a curve that starts with either a positive or negative slope, and in order to make it reach point B, it has to change directions at some point, and the sign of the slope has to change from positive to negative, or negative to positive. If the sign of the derivative is changing, then the derivative has to equal 0 somewhere in there, as 0 exists between positive and negative. This same reasoning applies to curves with more than one change in direction, because if there are 2 changes in direction, for example, then there are simply 2 points where the derivative equals 0. Now I'm going to move on to the mean value theorem, which looks arguably even scarier, but basically just says that if I have 2 points A and B anywhere in the plane, then they can be connected with some line that has a specific slope. And if I connect these 2 points with any sort of red curve that can be drawn without picking up my pen, and that has a derivative everywhere on the curve, then at least one point on my red curve has a derivative that equals the slope of my dashed line. In order to prove to you that the mean value theorem is true, all I have to do is take our example from Rolle's theorem and rotate it. Since all symmetries and properties are conserved through rotation in the Cartesian plane, the mean value theorem is true because it's just a rotated version of Rolle's theorem.